It's fine.
Yeah. All right, give it up for Wes.
So the title of my paper is Brain Feminization Requires Active Repression of Masculinization via DNA Methylation. Or the inhibition of DNA methylation causes the brain to become male. So does anybody know what makes your brain male or female?
Chromosomes.
Yeah. So every brain is actually destined for female phenotype. But if you have a Y chromosome, then during the prenatal sensitive period of, so when your brain is developing in the...
That's so wrong.
Okay. So when your brain is developing in the womb, then these gonadal hormones are released if you have a Y chromosome. And these gonadal hormones are masculinizing hormones, and they're going to make your brain masculine. So what is DNA methylation? DNA methylation inhibits gene expression. So here it's the blue is like the methylated, so it stops it so your DNA can't be read. And so they wanted to see how DNA methylation contributes to the masculinization of a brain. So just a side note, since I'll be talking about it a lot later, DNMT is DNA methyltransferase, which is the enzyme that catalyzes the DNA methylation. So they have the same effect. And all of these tests are being done in the pre-optic area of the brain, which is the blue part all the way over. So it's this part, and they're measuring the methylation at the CPG sites. So the first test they did was with estradiol. And so estradiol is a hormone that can have a masculinizing effect. When there's an excess of testosterone in your brain, in a male's brain, and it combines with aromatase, the enzyme, and that therefore creates estradiol. So what they did was they administered estradiol to females, and they saw that the females with the estradiol mimicked the same percent of methylation as the male controls versus the female controls. So the estradiol lowers DNA methylation, therefore lowering the gene expression. Next, they wanted to test the sexual behavior in rats by administering ZEB. So ZEB is a DNMT inhibitor. So essentially, ZEB is a double negative. Since DNA methylation inhibits gene expression, the ZEB inhibits the inhibition. So the ZEB allows those genes to be re-expressed. So they tested the sexual behavior, and they saw that the females with the ZEB mimicked the same sexual behavior as male controls. So essentially, when the females had their DNA methylation inhibited, they exhibited the same sexual behavior as males. So does anybody have any questions so far?
Can you go back one slide really quick? That's female with
Estradiol.
okay. So that masculinizes the female, and then this one is female, just female with ZEB, right?
Right.
So no estradiol.
No.
So are they using ZEB to mimic estradiol, or?
Kind of. They have, so they basically have the same effects. So this is just proving that the estradiol lowers the methylation, but this is proving that the ZEB, like, it makes, so this is like the first step. So, okay, so the methylation is lowered, but then this is the effect of the methylation, because the ZEB already has its DNA methylation inhibited. So it's saying that when it's inhibited, that's going to happen. So this is a chart of the ZEB gene expression. So I know it looks confusing, but just look at the colors. So the blue or the white is when a gene isn't expressed, and the red is when it is expressed. So if you just look here, you can see that a gene that wasn't expressed in the females was expressed in the male and the females with the ZEB. So the females with the ZEB administered mimicked the same gene expression, or mimicked the similar gene expression as males. So next they wanted to test the time period. All of this study had been done in this prenatal sensitive period, when they know that these gonadal hormones are released. But now they wanted to test, what if they did it 20 days after? So they saw that in females with estradiol, so the normalized optical density looks confusing, but it's essentially just another way to measure the DNA methylation. So they saw that females with estradiol administered outside of the sensitive period, they did not have a significant masculinizing effect. So that's just proving that estradiol, when it's estradiol or the gonadal hormones, have to be administered and it has to have contact with the brain during the sensitive period. However, they saw that ZEB did have a masculinizing effect. So when the females had their DNA methylation inhibited, then they saw that it did have a masculinizing effect. So essentially, they figured out that DNA methylation needs to constantly be happening in a female's brain for it to remain female. So when it's stopped, it starts to become male. So this is just a little summary of everything. So this on the top is the constant cycle in a female's brain. The DNA is constantly being methylated and it's constantly remaining female. This is what happens in the male brain. So this first step is just during the critical period, and the testosterone is converted to estradiol, and that estradiol stops this DNMT. So essentially the estradiol then makes this cycle not happen, and this cycle is what makes it female. So the estradiol then stops the DNA methyltransferase, and the DNA can no longer be as methylated. Any questions on that? Yes.
Wesley, can you just explain again what the role of aromatase is?
Aromatase is kind of like it's just when it's added. So in a certain time in your brain, for males, there's a ton of testosterone. And aromatase is in female and male brains, but since there's so much testosterone, this aromatase then converts the testosterone in the male brain to estradiol. So it's important, but it's important because it leads to the estradiol.
Thank you.
So what does this mean? Feminization is an active process in the brain monitored by DNA methylation. So DNA methylation is a part of epigenetics, and epigenetics is the effect of the environment on your brain. So essentially, this is saying that the effect of your environment on your brain then changes DNA methylation. And DNA methylation can change the gender of your brain. So essentially this is saying that epigenetics can determine or be have an effect on the gender of your brain. So thank you to Mr. D and the German Club team. Sid, Amanda, Mark, Catherine, Jade, Jen, Julia, Jack, and Adam. Thank you.
Could you go back to the previous slide? Thank you. I have a question about the epigenetics that you have up on the slide. I started thinking that if you have this continuous methylation, say on a physical or a biological male, is that going to lead to someone who's going to start thinking that they aren't transsexual? I'm thinking of Bruce Jenner, in case where he's going to be transitioning into a female. Is that a possibility?
Yeah, I think it definitely is a possibility. I don't think it really covered it enough in the paper for me.
Okay, that's what I wanted to know.
say or
Yeah, did you come across any reading about like estradiol in humans and
Mhm.
behavior? I think that's
That's what I'm asking.
No, I didn't, but I can.
no, it's
No, I'm just curious, Wilson.
Any other questions?
did they look at any other effects in mice of the estradiol or estradiol shutdown other than the threat behavior?
They looked at a little bit of aggression behavior and to test like if it was like male or female exhibiting.